Hi everyone, my name is Sinan. I am the founder of Mech Dynamix machine tools. We operate factories in both the UK and Turkey, specializing in the manufacturing of 5-axis CNC machines. Alongside our manufacturing business, we also run the Mech Dynamix Academy, where we train students from the technical colleges and universities in Turkey and the UK. In this video, we are excited to introduce a CNC machine that we have specifically designed and built to help you learn step by step how to build your very own CNC machine. While working with apprentices, we have seen a big gap between classroom learning and real-world CNC skills. So we decided to do something about it. That's why we created the CNC Workshop Academy, running hands-on workshops in colleges across the UK and Turkey. In this video series, we are taking you on a journey from understanding mechanical components and electrical systems to CNC controllers and software. And by the end, we will build a complete CNC machine together. So if you are ready to turn your CNC knowledge into real skills, let's get started. Let's start with the foundation of our CNC machine, the 30 by 60 mm aluminum profile. This profile will serve as the machine base, providing both stability and precision. The distance between its two channels is exactly 30 mm, which is important for our design. Now you might be wondering, why 30 by 60 mm aluminum profile I am using? Well, there's a widely used linear rail system in the CNC market called SBR20, and it is designed to fit perfectly on this profile. That means no extra modifications, making assembly easier and ensuring a precise fit from the start. Now, let's take a closer look at the SBR20 linear rail system and its sliding unit, the SBR20UU. The SBR20UU linear carrier is designed to slide smoothly along the SBR20 rail, making it easy to install and integrate into our CNC build. One key factor to consider with any linear rail system is friction. Lower friction means smoother movement and higher precision. While the SBR20 system is one of the most affordable options, it's important to note that its accuracy and friction levels aren't the best compared to higher-end solutions. If you are building a high-precision, premium CNC machine, you might want to invest in precision linear systems. But for a cost-effective build, SBR20 is a solid choice. For this build, I'm using an aluminum profile as the machine base. But depending on your budget and precision requirements, you have other options. Steel profiles, a more affordable alternative, though slightly heavier. Cast iron or mineral casting bases. The premium choice for high-precision CNC machines, these materials offer excellent vibration damping and are less affected by temperature changes, making them ideal for precision machining. Why does temperature matter? In highly accurate CNC machines, even small temperature fluctuations can cause position errors. That's why, in some cases, we place machines in temperature-controlled environments or install temperature sensors to enable automatic compensation. Choosing the right base depends on your project needs, cost, precision, and long-term stability. For this build, aluminum strikes a great balance. For our CNC machine base, we are using two 600 mm aluminum profiles and three 400 mm profiles. This forms a sturdy and balanced foundation for our build. But here is the best part: you can modify these dimensions based on your specific needs. If you are building a larger machine, you might go for longer profiles, while a more compact design can use shorter ones. The flexibility of aluminum profiles makes customization easy. Now, let's take a look at how we connect our aluminum parts together. We use a special type of nut called a T-nut. These T-nuts are designed for specific profiles. The one I am using is called T-nut slot 8, which is a perfect match for our 30 by 60 mm aluminum profile. It's incredibly simple to install. Just insert the T-nut into the channel, then tighten the screw to secure any component in place. This method ensures a strong and reliable connection every time. Next, let's talk about a critical component of our CNC machine, the ball screw and ball screw nut. The one we are using is called SFU2005. It has a 20 mm diameter and a 5 mm pitch, which means that for every full rotation, the system moves exactly 5 mm, assuming the motor is directly coupled. Important warning: the SFU2005 comes with the nut pre-installed. If you try to remove it without the proper support, the internal bearings will spill out. And trust me, putting them back together is a real challenge. High quality ball screws usually include plastic guide parts to help safely install or remove the nut, but this one doesn't. So I designed a 3D printed, a custom installation tool for the SFU 205. Another great feature of this SFU 205 ball screw is that it comes pre-machined at the ends. That means you don't need to take it to a lathe for additional machining. It's ready to use right out of the box. This saves both time and money, making the assembly process much easier, especially for DIY CNC builders. For this CNC build, we'll be using 3 SFU 205 ball screws and ball screw nuts. But depending on your machine size, there's something important to consider. If your x-axis is long, you'll need 2 motors and 2 ball screws on the y-axis. Why? Because when force is applied to the spindle, it can cause misalignment in the assembly. That's where a gantry system comes in. A gantry-driven setup ensures stability and accuracy, distributing the load evenly and preventing deflection. Now let's talk about the ball screw nut housing, a crucial component for mounting the ball screw to our mechanical system. The SFU 2005 ball screw and nut don't come with a built-in mounting point, so we need to use a ball screw nut housing to securely attach it to the machine frame. Ball screws need to be properly supported at the both ends to ensure smooth movement, reduce vibration, and maintain precision. This is where BF15 and BK15 support units come in. BK15 support unit is installed on one end of the ball screw, where it holds the screw firmly in place using preloaded angular contact bearings. This prevents axial movement and ensures stability. BF15 installed on the other end, the BF15 uses a single deep groove bearing, allowing a slight axial movement to compensate for thermal expansion and prevent unnecessary stress on the ball screw. Without these support units, the ball screw can wobble, create backlash, or lose precision, especially at higher speeds. Now let's talk about the 30 by 60 mm corner bracket, which we use to connect aluminum profiles together. Installing is super easy. Insert your T-nuts into the aluminum profile channels. Place the corner bracket in position. Tighten the bolts to secure the connection. One important tip: during assembly, make sure the profiles are perfectly aligned. This ensures structural accuracy and prevents issues later on. For extra precision, we'll double check alignment using a comparator clock when installing the rails. Now let's move on to assembling our SPR20 linear rail system onto the aluminum profile. First, we slide the T-nuts into the profile slots and align them with the mounting holes on the SPR20 rail. Once everything is in place, we begin tightening the bolts to secure the rail onto the aluminum base. But here's the important part: alignment is key. We need to make sure the rail is perfect, straight and parallel, as even a small misalignment can affect performance. Later in the process, we'll double check the precision using a dial indicator to confirm that everything is aligned correctly. Thanks for watching, and I'll see you in the next video as we continue building our CNC machine step by step.